Hello, everybody. Today we're going to be completing a full-length practice test on Unit 1 of Calculus AB. Let's get started with the first question. So it gives a graph of function h and the dashed lines are the asymptotes. So it wants to know where in the h it has an infinite discontinuity, which is also known as a vertical asymptote. And it's here and here. Let's see the answer choices. X equals -6, yes. X equals -2, x equals 4, no. That is just a removable discontinuity. This one has find limit as x approaches 2 of x plus 2 over x minus 2. Let's do direct substitution. So 2 plus 2 is 4. And 2 minus 2 is 0. 4 over 0 indicates that there is a vertical asymptote, which means that the limit does not exist. Okay, this one gives a table of values of g, and it wants us to find a reasonable estimate for as x approaches -8 gx. And it seems that when it's approaching -8, it is kind of approaching 0. Wow, wild guess was right. Okay, x approaches 2. We want to do a direct substitution, but I have a really good feeling that it's not gonna work. So this one's gonna be 8 minus 2. 4, 4, 8. Yep, it already gave us a 0. 4 minus 4. It's 0 over 0. That means we'll have to do factoring. So let's do factoring. X squared x minus 2 over x minus 2 x plus 2. And we will have to cancel these out. So now we're left with just this and this. Let's do another set of direct substitution, which will be 4 over 4, which is equal to 1. Next question, another table of values of f. Estimate for limit as x approaches -2 from the left. So we're going to look at the left-hand values and see it's not really approaching anything. It seems like it's going really, really high. That means it's unbounded. The function f is defined for all real numbers except for x equals -3. Yep, there's a vertical asymptote. What is a reasonable estimate for x approaches -3? Well, it already told us it's all real numbers except for this part. So the limit does not exist. Let f be a continuous function on the closed interval 1 to 5, where f of 1 equals 1 and f of 5 equals 3. Let's put that into a table so that I can read it easier. 1 is 1, 5 is -3. Which of the following is guaranteed by IVT? F of c equals 2. That won't be guaranteed because it's not between -3 and 1. It'll probably be either C or D. Between 1 to 5, it is C. Consider graphs A, B, and C. The dashed lines represent asymptotes. Which graphs agree with this statement? So we're trying to find as x approaches -infinity, it will equal to -4. Let's see. Negative infinity. Nope. That one approaches -2. Looks like this one's the only one that approaches -4 as x goes to -infinity. So another one of these, find as x approaches infinity. So this one, it's dealing with either Bobo, Betsy, Batu, if that's what you learned in class. So we're just gonna take the most important coefficients. It's a Betsy, which means that we can only have to look at the coefficients. Therefore, it is 1. This one is a big one. So if you plug it in, it's already 0 over 0. Seriously? Okay, this one we have to multiply both sides by negative 3x minus 5 minus 1, because this one's plus 1. Negative 3x, sorry, minus 5 minus 1. Terrible handwriting, but whatever, deal with it. Okay, if you multiply the top, let's just keep that there. 1 minus 5. This will just equal to negative 3x minus 5. And 1 times negative 1 is just negative 1. Sorry about that. This one is positive. Minus 1, it will be 3x minus 6, which is just 3x minus 2. This and this will cancel out. So now it's just this and over this. If we plug it in, it'll be 3 times 2, which is 6 minus 5, which is 1. And then negative 1 minus 1 is negative 2. So it's negative 2 over 3. And I may be confidently wrong, but clearly I'm not. I'm always right. Okay, consider the graph of function h. Which limit expressions agree with the graph? Negative 3, 3. Let's see. Negative 3, no, wrong. 3 from the right is 1. That is very good. Limit as x approaches 3 from the left does not exist. Clearly you are wrong. So it's just... This one looks like a pain in the butt, but let's just go with it. It's gonna be on your test. Let's do direct substitution. Pi over 2 is right here. And if it's cotangent, if it's tangent, it's undefined. That means if it's cotangent, it's just 0. 1 minus sine pi over 2. Pi over 2 is right there. Oh my god, it's 0 over 0. That means we have to do something. Okay, so I just did all that work because I want to be able to fit it in the video. So we're just left with this. Pi over 2. It will be 1 plus 1, which is 2. And then over 1 minus cosine squared. It is cosine of pi over 2. That would be 0. And 1 minus 0 is 1. So it's just 2. Congratulations, you completed that question. Next, find the limit of cotangent as x approaches pi over 4. So pi over 4 is right here, and we know the tangent is 1. That means cotangent is also 1. Easy AP pre-cal stuff. This one is a squeeze theorem graph stuff. This is so bad. H doesn't even have a limit to 1. So now, yeah, Kendrick, I don't know what you're thinking. Which limit expressions agree with the graph? Okay, x approaches negative 1 is negative infinity. Nope, opposite of what it actually is. 3 from the right is negative infinity. You're correct. Negative 5 from the left is negative infinity. No? Okay, we're doing good. Functions g and h are graphed. Find limit as x approaches negative 3. So we'll start with the inside part. In negative 3, it's 3. So now we gotta find g of 3, which is just 1. Okay, we got the correct answer. Congratulations. Which of the following functions are continuous? Logarithmic? That is not continuous. I think that looks something like this, and then there's an asymptote cotangent. That is not continuous, is it? I forgot, but I have a gut feeling it's neither. You can Google the functions on your own. I'm too lazy. Find g of 0. Girl, okay. 0 plus 0. Isn't that just 0? I mean, I feel like that's simple. Okay, that is the end of the video. I missed the question and I'm terrible. Thank you for joining and goodbye.